So this was a collaboration that we've just recently completed together with German DVAL. German KfW had been funding a whole series of irrigation investments in northern Mali for almost 2 decades, together with other donors, I should say. And then German DVAL Institute worked together with us to obtain the geospatial data for these locations and to design this analysis. So this was a whole series of irrigation locations in northern Mali, along the Niger River and some of its tributaries. This is pump-based irrigation, so mostly cases where often diesel-powered pumps placed in the river and water is pumped to nearby fields, or the pumps are placed in some of these tributaries. There is very staggered treatment over these 2 decades. So this was rolled out throughout this region. And as you can see, the different colors correspond to different years of treatment. Lots of variation over time and space here that we can exploit. As you can also imagine, lots of potential for spillover effects and other kind of complicating factors here as well. The data that we received from German KfW and then also some supporting data from the engineers, I'll show you that in just a minute, mostly in good GIS format, but also some PDFs that we'll look at in just a second. And the main design that we're going to have here is a panel design. So again, the assumption is that the outcome variables that we'll look at are not correlated with the timing of the treatment, conditional on the fixed effects that we'll throw in there. I mentioned DVAL. They were helping us frame the research questions, developing the conceptual framework. Really importantly, they were helping us coordinate with the consulting and engineering firms to obtain more project information and some of the underlying shapefiles. So we got a mix of shapefiles and something that looked like this image, a PDF, that we could then geocode ourselves by overlaying this PDF, as Seth was showing you yesterday, on Google Earth, and looking for particular points of interest that we could reference to then hand trace many of these particular lines that were already in the PDF. Again, in all these cases, if you can just directly get the shapefiles from the engineering firms, the consulting firms, whoever put it together originally, way easier and better. Not the end of the world. These are, again, recoverable if you have a sufficiently high resolution map like this. Also important, these had a lot of other details at the location level about the number of beneficiaries, the amount of money that was spent, cultivated hectares, etc. Lots of other important details at the unit level here for us, at the polygon level. Also had lots of polygons in the southern Sikasso region as well that we used, but these were much more recent and did not really let us do the full time series analysis to the same extent as the northern Mali case. So this was kind of a case that we explored and tried to do a little bit of, but in the end, I think was less convincing. So we use a bunch of different measures for this. One was satellite-based agricultural production, NDVI, and water availability as well. So the normalized difference of water index, things Kunmar discussed yesterday. Our main data came from the Landsat series, so 5, 7, and 8. We obtained this from Google Earth Engine along the lines that Kunmar showed you yesterday. The underlying Landsat series had 30-meter resolution, and series 5, 7, 8 satellites let us get very long time coverage, all the way back to 1986, but through 2021. We aggregated these, the measures are routinely aggregated to 16-day periods, and we aggregated them to either the rainy or main growing season and the pre-rainy season period as well. We wanted to see if the availability of irrigation extended the season earlier, let farmers start growing sooner, and also to what extent it made water availability much easier on nearby land. So in this particular context, lots of rainfall during the rainy season that then goes into the river itself, not necessarily as much on all of these distinct fields. We saw big impacts on NDVI, which is what we're showing you here during the growing season itself. So this is the Borusiak et al. Version of that two-way fixed effects estimator. So again, that was a case where we're using the not yet treated as a way to impute what's happening on the already treated units. You could see the pre-trends here are pretty clean, a little bit of bounciness, but nothing much happening on these polygons before irrigation happens. The first year of irrigation, we see maybe a slight uptick, but this may be also a little bit because of we're not entirely sure when the irrigation is installed, late in the season or early in the season, maybe even after the growing season. But in the second year, we start seeing meaningful upticks. And by the third year, we're at a much higher level of NDVI. And that stays very constant. It stays very constant over time. So you can see here, we're following this 15 years later, right? As I mentioned, we got 2 decades of these in a long run-up window, again, going back to 1986 for these. So we've got 10 years pre-data for a lot of these and 15 years post. So pretty impressive and pretty stable outcomes, even despite there being really dramatic swings in weather and water availability over those 15 years during which we're following these. So this is kind of one example. Again, Google Earth Engine processed NDVI measures and also NDWI measures for the polygons that I showed you earlier that we were able to obtain, upload to Google Earth Engine, extract these NDVI measures by growing season and pre-growing season, import all that into Stata, and run Borusiak et al. Two-way fixed effects estimator on it. So that was an event study design. Also, of course, important to think about pre-trends, not just in the event study, but also preceding a window of any treatment. So in this case, we had data going back to 1988 all the way up to 2002, which was before most of the interventions really kick off. So on the vertical axis, we've got the changes in the polygon mean NDVI during the growing season in those first 14 years. And then graphed against the horizontal axis is the year of treatment for the different polygons. And you can see that there's not a lot of meaningful variation here, which is what we're hoping to see, right? Even polygons or fields that were not irrigated till very late look very similar to some of the earliest irrigated fields in terms of the run up to that case. So pretty unlikely that there were big investments happening in these fields prior to the irrigation that meaningfully changed their trends in NDVI. In addition to this remotely sensed data, we also matched the DHS to these locations. The map here shows you the location of 5 rounds of the DHS going back to 96, 2001, again, mostly preceding any interventions, and then the 06, 13, and 18 rounds for our post-intervention periods. You can see, the coverage is decent. It's not a huge sample that we're going to be using here, but it's reasonable. The outcome measures that we focused on, primarily child stunting, wasting, and anemia, those were the outcomes that we thought could most directly be linked to the higher production of staple crops that was now available on the fields near these clusters. So of course, we can't link whether the individual household was farming or consuming food from an individual field, but we're just linking them based on proximity to these fields. We also use some of the mother's recall for birth weight, recent illness for individual children. Because we know the years of birth of the individual children, we can do this both based on their exposure since birth and then exposure pre-birth as well, So we can generate different timing measures for the individual children as well. This is some of the results that we find. Big effects before birth at the 2 kilometer and 2 to 4 kilometer windows. Big negative effects for the outlying regions at the 4 to 6 kilometer windows. Sorry, I don't have this on the graph, but about 2/3 of our sample is within 2 kilometers. So even though they're some of the smallest effects in terms of magnitude, in terms of the aggregate actual effect of the intervention, those top effects are the largest set of effects. And then we've got another about 17% in that middle 2 to 4 kilometer range, and about 16% in the 4 to 6 kilometer range as well from these interventions. There's not a lot of clusters that are located farther than 6 kilometers away from any intervention, again, partly because this was in northern Mali, where water is so scarce and so determinate of where locations are. We're not entirely sure what's going on with the story. We've checked a lot of potential mechanisms. We think part of it certainly could be displacement, where households are moving closer to some of this, so it's closer to some of the irrigated sites. But certainly we think there are major benefits close by. Some potential costs, although we can't, again, rule out that there's some selection story going on here. Okay. We also, I should say, used conflict data from ACLED and higher resolution satellite imagery to look at these as well. We don't have a lot of time to go into that, but tried to complement both the DHS and the Landsat-based analyses with other event data and other higher resolution imagery as well.